Welcome to Industrial PLC Applications. This video is on our continuing series on network communications. This is part 2, IP addressing and communication protocols. After completing this video, you should be able to explain IP addressing and explain the difference between TCP and UDP transport protocols. Before we begin, here's a note on network security and safety. Most Ethernet networks are set up with a high degree of security. This prevents unauthorized access, accidental or malicious changing of data or system parameters, or unintended machine movement or unexpected operation. Think safety first and always follow the policies and procedures for your employer or your customer. Many of the procedures discussed here require access to the network not normally available to typical users, so before working on a network PLC, contact the network's administrator to discuss the nature of the work to be done and the procedures to follow. Networks and networking depend on two vital things beyond the physical hardware. They need a system of reliable communication addressing and data stream protocols. As electricians in an industrial environment, we monitor and act as frontline administrator for PLC networks on the shop floor. So having a basic understanding of IP addressing and data stream protocols helps us maintain and repair these vital networks. Although there are many other data networks used in industry, such as Profibus, Modbus, and EtherCAT, we'll be looking only at the Ethernet over Industrial Protocol since it is the network used by the Micro 850 PLC. With the introduction of the Industrial Protocol, Ethernet is quickly becoming one of the most popular networks for automation control, since the communication equipment is affordable and readily available, and there is widespread familiarity with the wiring and installation. In part 1 of this series, we discussed an Ethernet device's unique fingerprint, its MAC ID, and how it is used by routers and switches to identify and link devices on a network or networks. Recall that MAC IDs cannot be changed. However, this can cause problems because networks are never static. The data traffic varies all the time. Just think of the internet. Understanding IP addressing helps you to find your devices. Billions and billions of devices are all randomly connecting to the World Wide Web, searching and opening trillions of web pages and exchanging data every millisecond. If every device had a fixed address, you wouldn't be able to use your cell phone because the web does not behave like a telephone system where you are only connected to one other phone. You are connected to hundreds of devices and websites and servers. To sort out the chaos and make sure everybody can jump on or off any time, industry standards were quickly developed. These standards had to make sure that not only would data flow quickly, but every device, regardless of manufacturer, could access the data and make sense of it. So they developed protocols. So let's look at the term communication protocol. What do we mean by that? Well, a communication protocol is a system of rules that allows two or more entities on a communication system to transmit information via any variation of a physical quantity. Protocol defines the rules, syntax, semantics, and synchronization of communication and possible error recovery methods. Protocols may be implemented by hardware, software, or a combination of both. The protocol you are most likely familiar with is Internet Protocol, or simply IP. Although, you likely have never realized it or even cared. And frankly, why would you? And that's the point. The system works without effort on your part. But as a system administrator, industrial electrician, you should know some of the basics. IP, or Internet Protocol, is a standard methodology of sending data from one device to another across the internet. This protocol determines how the data being exchanged shall be configured, packed, and unpacked at both ends of the transmission. Every device on the internet has an IP address that the network uses to pass data on its network and enables every device to communicate and exchange data with other devices connected to the internet. Internet Protocol is another very deep subject, far beyond the needs of the shop floor administrator. Here's what's important. 1. Understanding IP addressing. 2. Recognizing there are differences between protocol, as in the Internet protocol versus the industrial protocol. 3. Transmission protocols, or how the data is packaged and exchanged, and there are 2, TCP and UDP. And finally, IP masking and subnets. An IP address is an address used to identify a sender and a receiver device on an IP network. The address is made up of 32 binary bits, but it's broken down into 8-bit groupings called octets. This gives each octet a range between 0 and 255 in decimal. It's commonly displayed in decimal dot format. For example, 172.16.81.100. This is done to avoid eye confusion and to make it easier to say and remember. In theory, it should result in 4,294,967,296 different IP addresses. But a few have been removed for network use. We'll talk about that in subnet masking. There are 2 types of IP addresses. Static, which is a fixed IP address usually assigned by a network administrator or by an internet service provider, an ISP. For example, Rogers, Cogeco, Bell, etc. With ISPs, you have to pay a fee for a fixed IP because it impacts the flexibility of their service. IP addresses can be and must be reusable since there is a finite number of IP addresses at any given instant. Dynamic IPs are temporary IPs that are assigned by the router on the LAN or user side of the router and will change from sessional use to sessional use. A dynamic IP address is assigned each time a device connects to a network. Both the router and the computer use DHCP, Dynamic Host Configuration Protocol, to generate the dynamic IP address. DHCP is a process where a device seeks a communication partner. A lead device, such as a router, acknowledges the connection attempt and assigns a new IP address to the connected device. When the device disconnects, the IP address is released and is assigned to the next device connected to the lead device. Your home's router's WAN side does the same thing, and it's given its own temporary IP by the World Wide Web. BootP, or Bootstrap, is a protocol used when it is necessary to create a static IP on a network. When dealing with Ethernet devices on an industrial network, the PLC must be able to find the remote I/O every single scan. The remote I/O often has a factory set initial IP address, and this leads to an internal web server contained within the module itself. The IP address can then be manually changed to meet the requirements at the time. Internally, it's using BootP and often requires that the power be cycled to set the module's new IP. Just to be clear, in industry you will often see these 2 different spellings of Ethernet. One is a type of network and network protocol, the other is a registered trademark of a specific kind of network and protocol. Ethernet without the capital N is the Internet Protocol, but the capital N makes it the Industrial Protocol. The Industrial Protocol was developed from the Internet Protocol, but with a focus on industrial signals from these PLCs, HMIs, remote I/O, and safety devices, etc. They are similar but not the same, since the traffic priorities are completely different. PLCs, human-machine interfaces, safety devices, robots, and other Ethernet devices used in industry have different needs than the Internet. This is part of the reason for the different protocol. They all share the same things they must have. Static IP addresses that may or may not require BootP to set up. They must be able to use either UDP/IP or TCP/IP, and they must conform to the Common Industrial Protocol in the OSI Ethernet model. Let's take a quick look at the two transport protocols we just mentioned, TCP and UDP. TCP stands for Transmission Control Protocol. This protocol ensures data accuracy. It requires the following steps. 1. There is a request sent from a host to a user to open a mutual channel connection. 2. The host aligns the data that is to be sent, and after that, it sends it. 3. The user receives the data in the correct order. 4. The host requests confirmation of data receipt and accuracy. Once that is achieved, the connection is closed. UDP, or User Datagram Protocol, is referred to as a connectionless protocol in that it does not require a communication connection to be opened and locked while data sharing like TCP. What this means is that the transport protocol saves time by not opening and locking up communication connections. However, it does not confirm the proper receipt of data. This does not pose a problem if the data is constantly being updated, like a movie being streamed from Netflix or a PLC, which examines the I/O once every program scan. As for the preference between TCP and UDP, well, Ethernet over Industrial Protocol and PLCs use both transport protocols. It just depends on the nature of the data being shared. Before we get into masking and subnets, let's take a quick review of some of the different network types. There's a local area network, or LAN, which is a private network that connects computers and devices within a limited area like a residence or an office or building or campus. Then we have a large one called a metropolitan area network, which is a network larger than a LAN, and they can cover multiple cities or towns. Then you have a wide area network, which is a much larger network again than LANs or MANs. A wide area network can cover multiple provinces or entire countries. Keep this in mind when you start working with IP addresses. In all instances, the PLC being accessed will be on a local area network. Because the traffic can be high, it's important to filter out unwanted traffic on the network, or more accurately, filter the data to specific areas of the network. Subnet masks are used to section off one part of a network from a much larger network. During our discussion of IP addresses, it was mentioned that some are reserved and cannot be used. The following IP addresses are not available. 000.000.000.000 is 1 because it's not an IP address, it's 0. 192.168.0.1 and 192.168.1.0 are often used by routers as a home base IP address that you have access to set the router up itself. So those are not normally available to be used as a regular IP. Then we get into the subject of subnet masks. These are IP addresses that will add a series of ones to the IP address. We can use those to create sections of a network. So the table above lists the IP addresses that are used for masking out local area network IPs and creating subnets. This is done by putting the IP through a mask or filter and ending out portions of the IP by using zeros or ones in the binary number of the mask. And 1 in the mask means it will pass through. So 255.255.255.0 is really 8 ones, 8 ones, 8 ones, and 8 zeros. This means that the connecting PLC must be connected to the same network as the PC. In such cases, the subnet mask is always 255.255.255.0. There are other subnet masks in common use, so if this subnet mask doesn't work, contact the network administrator.